equations, but it's the same type of thing. We're trying to get to the point where we can solve it. Obviously, there's going to be some algebra involved, so your skills with algebra are extremely important. Some of you have really good algebra skills, others are still kind of trying to get by, so do the best you can. Here's some things for you to remember. One, first, write the equation with a trig function. Okay, number two, I'll give you examples here in a minute. Make sure it has 1 theta, not 2 theta. It's not that you can't deal with 2 theta, double angle formula, but just some hints about making things a little bit simpler. Okay? Number 3, use Pythagorean identity. If it's a sine and cosine only. And that's not set in stone. Obviously, if you have a secant squared and you see a tangent in there, definitely look at the Pythagorean identities for that stuff as well. But this is just to kind of give you hints towards solving some of the problems, okay? 4. Graphs intersect when f of x equals g of x. So we will probably use calculators for graphing so we can identify some things. Okay. Let's start with something that we might recognize. Sine squared of theta equals 4 minus 2 cosine squared of theta. Okay, so we have our first problem. We have sine and cosine only in this situation. Also, we notice that they're squared. All the more reason to use a Pythagorean identity. So what do you know about Pythagorean identities that you can use here with sine and cosine? What's the Pythagorean identity for sine and cosine? I'll wait. You have your reference sheets. You should know this one. Yeah. Sine squared plus cosine squared equals 1. Okay? Cosine squared equals 1 minus sine squared. And what you could have thought of is, well, what if I add 2 cosine theta to the left? I don't have sine squared theta plus 2 cosine squared theta. That's fine, except you have the 2 in front of it, and that doesn't match this. So I'm manipulating this equation to get rid of the cosine squared of theta and just only have sine squared of theta. It's just like a variable. This is an x, that's a y. If we can remove one of the variables, then we can solve for that one variable. So you have to try to bring your algebra skills back into this and look at your trig functions as variables and see if you can manipulate that way. So I'm going to substitute 1 minus sine squared of theta into that position. So sine squared of theta equals 4 minus 2 times 1 minus sine squared of theta. Substitution. Okay, what happens? Sine squared of theta equals 4 minus 2 plus 2 sine squared of theta. now I'm just going to get sine squareds by themselves. I'll subtract 2 sine squared of theta over to this side. And I get minus sine squared of theta equal to what? 2. Divide off -1. Sine squared of theta equals -2. Okay. You say, well, you should be able to do this. So I look at that and I say, well, wait a second. Again, I'm not going to take the square root of a negative number. So I'm going to go back and I'm going to look at this and see if there's another way that I can manipulate this. I deliberately did this a different way than what I have on here, just to show you some different answers as we go through. Alright, so you look at that and you say, well, wait a second, maybe I could go a different direction. What if I changed this and got rid of the sine squared instead of cosine squared, which is 1 minus sine squared. Oops, I'm sorry, 1 minus cosine squared. That equals the sine squared theta. Correct? So instead of sine squared of theta, I'm going to put 1 minus cosine squared of theta on the left. Good so far? Okay. So now we just got to put like terms together. No matter which way we go. Subtract 4 over to here, add the cosine of theta. Okay. That's -3. Add cosine of theta there. And we get negative cosine of theta. Cosine squared of theta. Divide by the -1. Negatives go away. We get 3 equals cosine squared of theta. Take the square root. When does x equal radical 3? Put your calculators out. Very simple example that you wouldn't understand unless you drew a picture. Because I looked at both of these two things. This one was obvious. I've solved it this way. This is not so obvious. What is the arc cosine of the square root of 3? Notice how I did that. I don't know what theta has to be to equal the square root of 3. So I did the inverse here. What's the arc cosine of the square root of 3? What do you get on your calculator? It died? Huh? Error?
I got an error.
You got an error?
Also did not.
Huh. What's the arc? Excuse me. Yeah, the arc sine of the square root of -2. Should you even bother trying that? Can you take the square root of the negative number?
No.
No. And unfortunately, this is the hint towards what's to come. You've done negative numbers under radicals before, right? Right? All that. Imaginary numbers. We're not there today, but I'm just giving you a hint. That's what's to come. This should have been your first clue that this is not possible. So if you looked at that and said, "Well, maybe I did it wrong," and then you worked it the other way and you looked at this, this looks like something that you could do, except cosine can't be greater than 1. Okay, we're talking unit circles. X can't be bigger than 1. Get out of here. Okay. X can't be greater than 1 for cosine. For sine, right? Okay, so that's just a quick example of, yes, it's possible to not have a solution. Got it? Same thing when we're talking inverses. They have those parameters that you learned with the inverses. Now let's do something different. Okay. First of all, you should be able to solve these based on algebraic ability and Pythagorean identities that you've been learning. Shall we do one that you can solve? You ready for one that you can solve? No? You're already done? Just real quick. Okay. Let's do, this is number 6. This is the cosecant squared of theta equals the cotangent of theta plus 3. Okay, so the first thing I noticed when I looked at this problem is I got a square. And always when I have a square, I either look to factor it, like algebra, or I look to my Pythagorean identities. Is there something in your Pythagorean identities that match cosecant squared? Dana, what is it? What is it? Yeah. 1 plus cotangent squared equals the cosecant squared of theta. Okay? So I'm going to put this in that position. And I say, uh-oh, I have like an x squared, and I have an x, and I have some other numbers. That's what I see when I look at that. And I immediately start thinking, maybe I have a trinomial here. And it's the same process. Just because you have trig functions doesn't mean anything different needs to happen. So I'm going to try and put everything on one side and try to get a trinomial. So cotangent squared of theta minus cotangent of theta. Oops. Is it plus or minus? What's left? Think a couple steps ahead. Everything on the left side. What are we doing? Subtract the 3 over here. What do we get? What do we get? Take. I subtract 3 over here on the left side. What do I get? Put the like terms together, please. Subtract 3. Thank you. X squared minus x minus 2. Is that factorable? What do you get? Think of it like this. What does that factor into? Shall I send home 80 problems of factoring tonight? Because I have a worksheet that has 80 problems on it. If you had me for algebra, you know what I'm talking about. Somebody factor this in the next 5 seconds, or you're getting extra homework from factoring. Four, 3. Alright, this is the same thing. Cotangent theta minus 2, cotangent theta plus 1 equals 0. Same thing. You all see that now? If not, you need to ask me for factoring help, and I will make sure you have plenty of help this weekend. That's ridiculous. Alright, now it's just like what we did yesterday. Zero product rule. Either this equals 0 or that equals 0. Okay, so the cotangent of theta equals 2, or the cotangent of theta equals -1. And yes, it's time to look at your radian mode on your calculator. What do you get? You can't do arc cotangent on the school's calculators. Some of the newer ones, I think you might be able to do that. But, so those of you who have the school calculators, how can I change this so I have the correct function? Another way of saying cotangent. 1 over tangent, right? Which tangent would be the reciprocal of this. And then if that's the case, tangent theta equals 1/2, I can take the arc tangent of 1/2. What do you get? I'm sorry, point? Yeah. So this one is 0.46. Same thing here. I can take the tangent of theta. That's still going to be -1, isn't it? So you should know what this value is without your calculator in terms of pi. Where are we at? Tangent must be 1 or -1. You are at what positions on your unit circle? Tangent is y over x. For y over x to be equal to a 1, they have to be the same values. Thank you, a 45-degree angle. Now the issue with this is tangent is between negative pi over 2. Our tangent is between negative pi over 2 and pi over 2. Tangent falls between that when you're graphing it. For it to be negative, where are we? Are we at pi over 4 or are we at negative pi over 4? Negative pi over 4. Alright. So, and both of these are plus k pi. Just like yesterday. Why is it only k pi, not 2k pi? Because your range, your domain, remember looking at that on the graphs, your domain and your range only goes, the period is pi, not 2 pi. Otherwise, we would have to look at the other side of this, the other part of the unit circle. Okay, so it only goes from negative pi over 2 to pi over 2. So this, you guys should have this on your reference sheets, the inverse information. If not, you need to put it there, just to remind yourselves of this, okay? I really, on the test, am wanting to see this. I know you guys are struggling with this stuff. This is, after you work it all out, then you should be aware of what your domain and ranges are, okay, from your graphs. The whole purpose of graphing was to make sure you were aware of your parameters, okay, and I know you struggled with your graphing. Okay, that's that one. Again, this is just a continuation of yesterday. You just have some more difficult problems. Notice it's really all algebra at this point. All right. Let's see a harder one. Yeah, let's do a harder one. Tangent of theta minus 3 cotangent of theta equals 0. There are no squares here, nothing specific. There isn't anything really with tangent, cotangent that is helpful. So let's start manipulating what we have. So anytime you get to a point where you're looking at it going, there is really nothing on my reference sheet to help me. There's no squares, I can't use Pythagorean identities at this point. So let's manipulate what we have. What's another way of saying tangent? Well, in terms of trig functions. Sine over cosine. So sine of theta over cosine of theta. So at the beginning of the chapter, we were really working on manipulation, and this is why. When you come to a problem, you just don't know, you don't have anything to help you, then you must change the way it looks to help you. It's the exact same thing in algebra. If you got an equation that you're looking at going, I have no idea what to do with this, there's nothing here, so you have to start moving things, either distribution, like combining like terms, trying to eliminate, doing substitution, whatever it is you've been taught to change the way it looks. This is the exact same thing. There really isn't anything up there to do anything with besides manipulation, what we did in section 1. Okay, minus another thing for cotangent. Cosine over sine. Excellent. fractions. You have two fractions. What do you normally do when you have two fractions and there's addition and subtraction? Yeah, put them together. And how do you put them together? You get a like denominator. What are your like denominators? Well, cosine of theta times sine of theta. So I need a times sine of theta over here, top and bottom. And I need a cosine of theta down here and up there. And look what happens. We get sine squared of theta. Oops. Minus 3 cosine squared of theta. All over sine of theta, cosine of theta. Now this is going to really stretch you. I can't do anything with that. I would love for it to look like that. Wouldn't I? Isn't that the same thing? One cosine of theta minus 4 cosine of theta, doesn't that give me minus 3 cosine of theta? Yes? Yes or no? This minus that, doesn't that equal minus 3 cosine of theta?
Yes.
Okay. So all I did was introduce something in here, like terms, combining like terms in backwards, so that I could get something that I wanted. So far, so good. Doesn't look like it's helpful. And guys, this is really hard to do, but you have to think outside the box. There is nothing to do up here, so we changed it, and it looks like it's getting worse, but you don't know that. Remember, sometimes it looks like it's getting worse before it gets better. We have 1 minus 4 cosine squared of theta all over sine of theta, cosine of theta. What's it equal? What's it equal? Zero, right? Well, in order for this to be 0, 1 minus 4 cosine of theta, 1 minus 4 cosine squared of theta must be 0. Doesn't matter what the denominator is, the denominator can't be 0. But the top must be 0. Can I not solve this? Subtract 1. Negative 4 cosine squared of theta equals negative 1. Divide by negative 4. Cosine squared of theta equals 1/4. Take the square root. Cosine of theta equals plus or minus 1/2. And there you have yesterday's homework. There's nothing new here. It's just that you've never thought to do backwards combining like terms. But that is a possibility. And you could just keep manipulating forever, back and forth, until you finally get to something. But my point is, you have to do something. You got to change it somehow. And yes, I am giving you odd problems to look at that stuff, so that you're not spending an hour on one problem going, I don't know what to do. But if you don't learn something, if you don't take away something from those problems, you are going to hurt yourself on the test. Your homework is 20% of your grade. Quizzes and tests are the rest. So you better be ready to be able to do stuff like this. So take each of those problems that you're going to do tonight and take away what they've shown you. Take from it, all right? And then you got to finish that. So what is x 1/2? What do you have on your unit circle? When is x 1/2? Pi over 3. And when is x negative 1/2? 2 pi over 3. Okay? As far as I'm concerned at this point, I want you to be able to get there. Alright. That was 12. Pretty accurate, isn't it? You want to go back to the formulas? Nobody said this was going to be easy. I said it was easier. Just continuation of your algebra. Okay. How about this one? 18. 3 cosecant square root of theta equals 4. So immediately I see the square and I think, well, maybe I should change it. Except, let me ask you something. If you had 3x squared equals 4, how would you solve that? Yeah, you divide by 3 and then you take the square root. Nothing wrong with doing that. Let's try and see if we can get an answer. Divide off the 3. So cosecant square root of theta equals 4/3. Take the square root. Cosecant of theta equals plus or minus 2 over radical 3. Good so far? What is another way of writing cosecant? Because it'd be great if that was radical 3 over 2. If it was a reciprocal, right? Well, what do you know about your reciprocal identities? What's cosecant? 1 over sine. So the sine of theta would be the reciprocal of that, plus or minus radical 3 over 2. When is y radical 3 over 2? Let me get a circle. 60 degrees, which is pi over 3. When is it negative? Well, it's giving you a limit in the book, which I can tell you from 0 to pi. So from 0 to pi, what's the other value at 60? 0 to pi. Your y value, what's that value? 2 pi over 3. So in your book, they're going to give you some limitations of which values they're looking for. Okay. So if they're only going from 0 to pi, if I want all the solutions, there you go. Limitation is only 1 pi, so I need to write it like that. Good. This is just continuing from yesterday. How about we look at something crazy hold down? Let me see for anything. Okay, 3 tangent cubed of theta minus 3 tangent squared of theta minus tangent of theta plus 1 equals 0. What if they were all x's? You got 4 terms up there. What would you do? But they all don't have x's. If they all don't have tangents. Curious. One of the last things in factoring in algebra that you were taught was grouping. 4 terms. Anytime you see 4 terms, you should do grouping. What can I factor out of that?
3.
What? Okay, so 3 and a tangent squared. Okay. So 3 tangent squared of theta. And what's inside that? Tyler?
Tan theta.
Tangent theta. If I divide each of these by 3 tangent squared theta, what do I get? Tangent theta minus 1, thank you. Over here, can I factor anything out? Always, at the very least, a 1. Okay? And if there's a minus sign in front, factor out a minus 1. I get positive tangent of theta, and then this becomes minus 1. Are these the same? If they're not, then you did it wrong. So grouping means you have to get the exact same parentheses. Now, from this group, I'm going to factor out what's common, and it's that parentheses, tangent of theta minus 1. And then I'm left with, 3 tangent squared of theta minus 1 equals 0. And now you have what we did yesterday, zero product rule. You got to solve each of them. Tangent of theta minus 1 equals 0, and 3 tangent squared of theta minus 1 equals 0. Everybody solve those right now. I've been doing it also. Again, on the test, I probably won't pick something like this. I'm not saying I won't. I probably won't. I have not finished the test. These are possible, just like that. You'll see on the pretest what's possible. So you need to make sure you look at all that stuff. All right, let's see how we're doing. Well, I'll come back. Just think how far you guys have come. I'm amazed in the springtime. We're not quite to spring, but I'm amazed at how much you guys have actually learned this whole year. You may be just hanging on by a thread, but look at how much you've learned. You may not be the A student that you hope to be. Some of you are. But you should think positive about your experience because you've learned so much. What about the other one? Did you do them both? Did you do them both? So add 1, tangent theta equals 1. First of all, when does y over x equal 1? Pi over 4. Not only pi over 4, but in the third quadrant as well, except tangent doesn't go into the third quadrant here. Tangent's between negative pi over 2 and pi over 2, right? Okay. Add 1 divided by 3. Tangent squared of theta equals 1 over 3. And everybody should recognize right away that the tangent can be 1 over radical 3. And everybody should notice it comes from this. That's all right. Wow. But the 2's cancel out. What is this? Y is 1/2. X is radical 3 over 2. Where are we at? Y is 1/2. X is radical 3 over 2. Where are we at? 30 degrees, which is 5 or 6. Good? Did we miss anything? Braxton, did I miss anything? What happens when you take the square root? What do you get when you take the square root? Plus minus. So there was another one there. Okay. Alright, pay attention to what you're doing. I know there's a lot here, but this is just algebra with trig functions. And manipulation, which is algebra. Huh? Yeah, and it's a lot harder. Okay, here's your assignment. Get this on video here. Your assignment, I said, I didn't say. How about these? What page is it? Somebody look up what page it is. Jim, you got your equipment. What page is it? 7-5 homework.
Slide 28.
Thank you. Number 3. Number 7. Number 13. 19. 25. 39. 43 and 53. Okay. There you go.